Now we're going to look at how can we use the quotient rule. And necessarily, what's our question, right? What is the quotient rule? And how do we use it? Well, the first thing I want you to think about is, when we said product rule over here, we were talking about multiplication. So I'm going to write multiply. When we talk about quotient, it's the opposite of the product rule, right? So the opposite of multiplying is dividing. So right here I'm going to put dividing, put the division sign. So product means multiply, quotient, dividing. So I want you to think about inverse operations. The opposite of multiplying is dividing. So think about this rule. The opposite of using a product rule to add the exponents is going to be the division, right? Which means we're going to subtract the exponents. So let me show you what that looks like. Now here's how when you do these problems, you do always have to start with the numerator. So my numerator has a power of 10. So I have x to the power of 10. That's my numerator. It goes first. I'm going to put a little first sign here. Then you're going to subtract the power of the denominator. So that one goes second. So we're going to put minus 3. And then when we work this out and simplify it, it's going to be x to the power of 10 minus 3, which leaves me with x to the power of 7. Because 10 minus 3 gives me 7. And that's my final answer. So it is literally the opposite of what we did in a product rule. So let's take a look at this next one. I am going to write this out to give me some space to spread things out, make it easier to read. So I got 1 times x to the power of negative 8. That's my numerator. And then for my denominator, I have 2 times x to the power of negative 10, right? That negative 10 right there. So we got this all written out. So what I'm going to do here, I'm looking at this and going, well, I can't further simplify 1/2. 1 divided by 2, that is a fractional value. So I'm just going to rewrite it as my final answer, 1 times 2. But my x to the negative 8, I can write that out, times x to the power of negative 8 minus negative 10. So we had our numerator, which is x to the negative 8, and our denominator was x to the negative 10. Now, I do want you to realize that you now have a negative sign in front of a parenthesis. We need to distribute this negative sign, which means we have negative 1 times negative 10, which turns it into a positive. Remember, a negative times a negative gives you a positive. So we're actually going to have negative 8 plus 10. So when we read our final answer, it's going to be 1/2 times x to the power of positive 2, because negative 8 plus 10 gives me 2. And that is my final answer. Now I want you to try this last one on your own. So pause this video, give it a shot, and then hit play and see if you get the same thing I got. Now in this one, I'm going to break it apart just like we did the other one. I'm going to have 15 times x to the 4th power times y to the 6th power over 3 times x to the 2nd power times y to the 4th power. So now that I got this done, I'm looking at it going, well, I can get rid of my constants because I know how many times 3 can go into 15. So 3 can divide into 15 evenly 5 times. The next thing I need to do is go ahead and get my x. I have x to the 4th power. So I'm going to say, okay, now times x to the 4th power minus, because remember we take the numerator, and then from the numerator we subtract our denominator if it has the same base. So that's x to the power of 2. So it's x to the power of 4 minus that 2. And then we have this y to the power of 6. So I'm going to say, okay, times y to the power of 6 minus our denominator, which is y to the power of 4. So it's going to be minus 4. So now that I got this all written out, it's a lot simpler than what it was. I'm going to go ahead and finish doing this math right here. I'm going to bring down my 5. And then x to the power of 4 minus 2 gives me x to the power of 2. And y to the power of 6 minus 4 gives me y to the power of 2. And that is my final answer. And let's not forget to fill this in. When dividing monomials that have the same base, you subtract the exponents. So that's what we just did, right? We had the same base, and it was dividing, so we subtracted the exponents.